Hello guys, welcome to Geeks4Geeks. In this video, we will learn how to find length of a linked list in both iterative and recursive ways. In other words, we have to write functions to count number of nodes in a given singly linked list in both iterative and recursive ways. For example, if the given input linked list is 13121, then the output will be 5. Let us now look at the algorithm to do this in iterative way. According to this algorithm, we have to first initialize a variable count to 0 and a pointer to point to the head node. Then we will check whether this pointer is null or not. If this node is not null, we will change this pointer to point to the next node and increment the value of the variable count by 1. We will repeat these two steps until the value of the node becomes null. Finally, we will return the value stored in the variable count. The basic idea behind this algorithm is to first initialize a variable to 0 and then increment the value of the variable by 1 every time we traverse a node, starting from the first node, so that when we reach the last node of the list, this variable will contain total number of nodes present in the list. Let us now look at step-by-step explanation on how this algorithm is working. Consider a sample linked list as shown here. We will first initialize a pointer to point to the head node and a variable count to 0. As this node is not null, we will increment the value of the variable count by 1 and change the pointer to point to second node. Now the value of variable count is 1. Again, this node is not null, so we will change the pointer to point to third node and the value of the variable count becomes 2. Again, this node is not null, so we will change the pointer to point to fourth node and the value of count becomes 3. Now we are at the last node. As this node is not null, the value of count will again incremented by 1. So the value of count becomes 4 and the current pointer will now point to the next of last node. So the current pointer becomes null. As the current pointer becomes null, we will now return the value stored in the variable count. As the variable count stores total number of nodes in the linked list, we will get the length of the linked list. Let us now look at the implementation of this iterative function. As the function returns an integer value, the data type of the function is int. This function is taking the head node as argument. We will first initialize a variable count to 0 and a pointer to point to the head node. Then we will increment the value of the variable count and change the pointer to point to the next node until this pointer becomes null. Finally, we will return the variable count. We have now learned the iterative way to calculate total number of nodes present in a linked list. Let us now move to the recursive solution. Let us now try to understand the algorithm or pseudocode of the recursive function. As you can see, the recursive function getCount is taking the head node of the linked list as argument. It then checks whether this node is null or not. If this node is null, then we will return a 0. That is, no elements are present in the linked list. If this node is not null, we will return 1 plus number of remaining nodes. As this function getCount here will return the remaining nodes in the list, as we are passing the argument of the next pointer to the function. Let us now understand this algorithm with the help of an example. Consider a sample input linked list as shown here. The function getCount is first invoked by passing the head node of the linked list. This will return 1 plus the remaining node of the linked list, that is 1 plus getCount function is invoked by passing second node. Again, as second node is not null, it will again invoke 1 plus getCount by passing third node. Again, the third node is not null, so it will return 1 plus again invoking getCount by passing fourth node. Again, the fourth node is not null, so it will invoke getCount by passing the next of the fourth node, but the next of fourth node is null. So this will return a value 0. In turn, the function getCount with the argument fourth will return 1 plus 0, that is 1. Now the function getCount with the argument as third node will return 1 plus 1, that is the value returned by the function getCount where the argument is fourth node. So the function getCount with the argument third node will return a value 2. Again, the function getCount with the second node as argument will return 1 plus the value returned by the function getCount when the argument is third node. So the function getCount second node will return a value 3. And finally, the function getCount head will return value 4, which is the length of the linked list. Let us now look at the implementation of the recursive function. The function getCount will take the head node of the list as argument. It then checks whether this node is null or not. If this node is null, it will return 0. This is also the base case of this recursion. If this node is not null, it will return 1 plus remaining number of nodes, which we will get by invoking the same function by passing the next node as an argument. This is the implementation of the recursive function. By this, we end our tutorial. Thank you for watching. Please leave us your comments.